Hello and welcome. Thank you for choosing our Extensible Markup Language or XML course. In this course, we're going to discuss what makes XML the default language for defining and transmitting data on the internet. Why is XML so important in empowering data interchange on the internet? We're going to learn the details of an XML document from both sides, how to read the XML document, as well as how to define our own XML documents. Think of XML as a briefcase that enables us to wrap our data into a format that we can pass off to others, and those others can interpret the data in that briefcase without any other information from us, because the data within the briefcase, the data encapsulated or described by the XML language, is self-describing. This gives us a level of simplicity for transmitting data to others over a network like the internet. It provides accessibility and a standardized way of transmitting data to others over a network. And it supports multiple applications. So let's dig in and go discover XML. In this course, we're going to have sections of discussion about XML and certain details that we'll cover in each section. That section will be followed by a demonstration, a hands-on demonstration which you are urged to take part in. Follow the steps of the demonstration. Repeat the demonstration on your own. Everything you're going to need, from the files, the data, anything you're going to need to accomplish the exercise in the demonstration is provided for you. We learn by doing, so you must replicate the steps that we cover in the demonstrations to solidify your understanding of XML and its power as a data transmission protocol. As we said, XML stands for Extensible Markup Language. It's very much like HTML in its structure. They both use tags to describe data, but there's some major differences. HTML has predefined tags, and its purpose is to present data, whereas XML is designed to store and transmit data, and the tags in XML are not predefined. We define the tags that describe our data. So if you've seen HTML, or maybe even you program HTML, you'll be kind of familiar with the structure of an XML document, in so much as we use tags in both XML and HTML. The big difference is that we're not limited by a predefined set of tags in XML. We create our own to describe the data that we're storing and transmitting. Again, big difference between XML and HTML is XML provides no formatting for the data. It's simply a structural language. It allows us to create self-describing data using the tags within which the data is embedded. A reader or receiver of that data, without any other information, can parse the data and use it within their own system. This makes XML amazingly powerful for information interchange and sharing. And the sharing of the data isn't limited to homogeneous systems. So we can have a Windows system or a Mac or a Linux or any other proprietary system transmit data in XML, and that data can be used, can be consumed by any system because XML is standardized. One of the most popular uses of XML is in the support of web services. and we're going to see examples of that. XML is a standardized language, and the standard that defines XML is controlled by the W3C organization. That standard provided by the W3C defines the structure of not only the XML document, but the document type definition for that document, the DTD. It is the document type definition, the DTD, that defines the structure of the data that's going to be interchanged. And by having a DTD, we can define specific XML document formats for data interchange within specific industries. And if we're a hospital and we're exchanging information with the government or with another hospital, then we can have a predefined DTD for that information interchange that we've all agreed on, making the information interchange that much more efficient. So starting out with XML, we need to understand that there are two basic parts of an XML document: the elements and the attributes that might describe the elements. An element marks a section of a document. It marks some data portion of the document, and elements may be nested so that we can have hierarchies of data within the document. And an attribute, which is optional, may be used to provide additional information about an element. Unlike HTML, XML is case sensitive. That means an uppercase has a completely different meaning than a lowercase in the language. So here's an example of an XML document, a simple XML document describing customer data. The very first line in any XML document, that is the first line before any white space, must be the declaration. We'll talk more about the declaration, but in this case, the declaration tells whomever is reading this document that the document consists of data that's encoded using XML version 1.0, and that the encoding uses the character set ISO 8859-1. So this is the first line, even before white space, within our XML document. The next line is the customer tag. And notice the structure of the tag. The less than sign, a name, an identifier, and the greater than sign. This constitutes a tag. And in this case, the customer is our root element. It is the element that contains all other elements in the document. You'll notice also that unlike HTML, which is very forgiving for unclosed tags, if we forget to close an XML tag, the XML file will generate an error. So we must remember to always close the tags. The tags occur in pairs, an opening and a closing tag, the pair. Within our root element, we have child elements. Again, the element tags occur in pairs. The first name tag, last name, the gender. The data contained within the tag for this example is highlighted with a red font. A consumer of this data would use the tag first name in order to be able to read the data for the first name associated with this customer. Likewise, the last name, the gender, the address, and the address itself has child elements: street, city, state, zip, and country. Within each of these tags, a consumer of this XML file would be able to extract the data that they're interested in simply by scanning these tags. So if a consumer of this data, someone to whom we transmitted this XML file, wanted to extract this customer's first and last name, they would know based on the description of the data to go to the tag first name and then go to the tag last name to extract that data, John Smith. And likewise with all of the other data that's provided in this XML sample. So XML tags occur in pairs, an opening tag and a closing tag. Everything in the XML document must be enclosed within the root tags. The root tag is the parent element. It is the topmost element in the XML file. Every XML document must have a root tag. This is the topmost tag that encloses all of the other elements within the XML document. And there can only be one. It is the topmost element within the XML document. Any element may have child elements, so that there may be a hierarchy that exists within the XML document, much like we saw in the previous example with the address tag having child elements of its own. So the general structure of the XML document is the root tag and then any child tags. And a child tag can have subchild tags. And the subchild tag can have children tags as well. In XML, we think of a tag as a container of data. And the largest container in the XML document is the root tag, which contains all of the other elements or containers within the XML document. So a container, a tag, may contain other tags or containers. Many of us describe an XML document as a tree, where the root tag is the base of the tree, and the leaves of the tree are represented by the tags that have no children. So they are the leaf tags. In our example, the root tag, the enclosing largest container in our XML document, is customer. The leaves of our XML tree are represented by the tags first name, last name, gender, phone, and email, because these tags contain no children tags, no subchild tags. Therefore, we refer to them as the leaves on the tree. The address tag, on the other hand, is referred to as a branch of the tree because it does contain child elements. And it is those child elements that are the leaves because they don't contain children elements themselves. They contain data, city, state, street, zip, and country. So by definition, an XML element begins at the opening tag and ends with the closing tag. As we've said, an element may contain other elements, but an element may also have an attribute or attributes. And an attribute simply provides additional information about the element. The attributes are included within the start tag or the opening tag of the element. Any value that we assign to an attribute must be quoted. Whether that's a single or a double quote, it must be quoted. In this example, we've modified our first example and removed the element gender from our XML and instead incorporated that information in the root tag by using an attribute. In this case, the attribute is called gender and its value is male. So this example of the customer information that is identical to our previous example provides the same information to any consumer of the data. But in this case, rather than using an element to define the gender data, we're using an attribute and including that attribute within the opening or start tag of our root element customer. Like any language that we use to communicate with a computer, XML has a set of rules, and those rules are referred to as a syntax. It is the rules by which we can write an XML document so that it is understood by not only our computer, but other computers that are parsing or processing that document. And like any computer language, XML has what are referred to as special characters, characters that mean something to the language. Therefore, we cannot use them within our data because it would confuse the processing of the document. In the case of XML, we only have two special characters that we need to be concerned with, and that is the less than sign and the ampersand. Because the XML processor, when it's parsing or processing our document, interprets these two symbols to have some XML meaning. If we include these symbols within our data, then the processor cannot discern between, did we mean that this symbol has its XML meaning, or do we mean that this symbol is just part of our data? Therefore, we need to define for the processor what we mean when we use these characters. And we do that by substituting the characters for what's referred to as an entity reference. And there are 5 predefined entity references. If we want to use the less than sign, then we're going to use the ampersand LT so that we don't confuse the XML processor. Same thing with the greater than sign, the ampersand, the apostrophe, and the quotation mark. Continuing with the syntax or the rules of the XML language, there are rules for the naming of our XML elements. And these rules allow the XML processor to have an expectation for the name of the element. Although white space and the formatting of our XML document is immaterial to a computer processing that document, we use white space liberally in the creation of our XML documents so that they are more human readable. Has absolutely no bearing on how the computer processes the XML, but makes the XML document readable to a person. When we're creating our XML documents, we often want to include a comment, a description of the data that we've included within the XML document. We do this by using a special syntax within XML. And if you're familiar with HTML, the syntax for the comments in XML are identical. A less than sign followed by an exclamation point and 2 dashes begins the comment. 2 dashes and a greater than sign ends the comment. Anything that we put between these two symbols will be ignored by the XML processor. So let's go look at some code.